Hello, everyone. Welcome back to continue the learning of this chapter. In this section, we'll talk about preprocessing data. Data preprocessing is also an essential part of iProject development. After learning this course, you will understand the meaning of data cleansing and how to clean data. You will also learn about tools for data visualization, as well as methods for value replacement, data normalization, and data division. When inputting data, we may miss some data, intentionally omit data due to its high costs or sensitivity, or incorrectly input data. This leads to missing values or outliers. It would be very inefficient to manually preprocess the missing values and outlier. But if we directly delete them, the data will be distorted. If we do not preprocess the data quality will be poor, resulting in deviations in the analysis. Therefore, improving data quality is crucial. We have the following ways to clean data. For missing values, we can fill missing values. The main methods include manual filling, eigenvalue filling, mean imputation, hot-deck imputation, and the use of k-nearest neighbors and regression values. For outliers, we often delete, convert, or merge them to improve data quality. In this way, we can train satisfactory models and obtain desired analysis results, so as to mine the real meaning of data. We use data cleaning methods to fill missing values and make sure there is no outliers. Next, we will move to data normalization. Why is data normalization necessary? We know that different evaluation dimensions or descriptions are based on different evaluation indicators. In other words, data has different orders of magnitude for different dimensions. Some has larger numeric values, which may affect the training model, because the data with large numeric values may be of little importance. Therefore, if data is not under the same dimension, the model training may be meaningless. Generally, min-max, z-sor, and logarithmic normalization methods are used. After data is preprocessed, we will split the data into the training dataset and test dataset. The training dataset is used to train the model, and the test dataset is used to test the performance of the model. The ratio between the training dataset and the test dataset is about 4:1. Specifically, we split the dataset into 5 parts. 4 parts are used as the training set, and the other 1 part is used as the test set. Or there could be other options. When training a model, we may split the training set further into more training sets and a validation set. In this case, we can use the k-fold cross-verification method. If we use the 5-fold cross-validation method, we divide the training set into 5 parts. When the model is trained for the first time, the first part is used as the validation set, and the other parts are used as the training sets. For the second training, we use the second part of the dataset as the validation set, and use the other parts as the training sets. In this way, we will get 5 models and 5 results, and the average value of the 5 results is used as the final evaluation result of the model. Validation sets are often used to search for some custom parameters. Next, let's look at the code. First, import the misignore function to check whether there are missing values. After confirming that there is no missing value, we will use the Seaborn package to draw the data to get an intuitive view. Then we can replace the abbreviations of cities. For example, replace HZ and WZ with Hangzhou and Wenzhou respectively, and replace the payment method with numeric values such as 0, 1, 2, 3. The apply function is used to replace the values. We use the input function to enter the city area and goods to be predicted. Then we can view the data after filtering. Next, we will delete the city area and time series. We use the sales volume of water as the prediction target. That is, the label of the sample. Other columns are used as features, so that the sales volume is predicted based on these features. After obtaining the features and corresponding labels, use the logarithmic function to convert the features. And once data is normalized, use the train test split function to divide the features and their labels into 4 parts. Namely, the training set, test set, training labels, and test labels. The ratio between the training set and the test set is 7:3. The last parameter random state defines the seed node. Ensure that the samples are the same for each division. Next is the code demo. Like run the last session codes, we can continue to run the following codes. If you close the Jupyter, you should run these codes from beginning. Now I show you continue to run this part codes. That's all for the code in this section. As usual, I'll leave 2 questions for you to think. Question 1. To improve data quality, is it correct to delete missing values? No, it is incorrect. As a result, the dataset will be incomplete if we directly delete the data with missing values, especially when the dataset is small. By deleting outliers, we actually mean imputation or normalization, which can improve data quality. Therefore, correct options for this question are BCD. Question 2. Which of the following methods can be used to normalize data? Z-score, min-max, and logarithmic are normalization methods, but index normalization is not the data normalization method. This section describes how to clean data, normalize data, and divide data to facilitate model training and testing. I believe after learning this section, you now understand the importance of data pre-processing before training the model. That's all for this section. Thank you for watching. See you next time.